Alright, today we're going to do special products. The first one you need to know is the square of a sum. So you have a sum with a plus b and you're squaring it. When you do that, you're taking a plus b times a plus b. Really, instead of having to fool it out, all you need to know is that you square the first one. You take 2 times the first one times the second one, and then you add the square of the second one. So a squared plus 2ab plus b squared. So instead of doing x plus 4 times x plus 4 and fooling it out, instead what we do is we square the first one. We do 2 times the first one times the second one, which 2 times 4 is 8. And then we square the second one, which 4 times 4 is 16. Alright? If you want me to prove it to you, I'll show you. Do x plus 4 times x plus 4. You get x squared. You get 4x, you get 4x, which adds to 8x, and then 4 times 4 is 16. So the square of a sum comes out to this always. The square of the first one plus 2ab plus the square of b. Any questions? 3x plus 5, we're going to square it. So this is the square of a sum. So I take the square of the first one, 3 squared and x squared, so 9x squared, plus 2 times the first number times the second number. 2 times 3 is 6. 6 times 5 is 30. And then the square of the next one, which is 25. So there's my answer. 8c plus 3d, and we're squaring it. So I do the first one squared. 8 times 8 is 64. C squared. I do 2 times the first number times the second number. So 2 times 3 is 6. 6 times 8 is 48. CD. And then I do the last number squared, which will give you 9d squared. There's my answer. Square of a difference. So I have a minus b. We're squaring it. So I would do a minus b times a minus b. I could FOIL that, and this is what I get. A squared minus 2ab plus b squared. The only thing different than square of a sum was that this is negative instead of positive. That's the only thing that's different. So let's do x minus 3 squared. I would do x minus 3 times x minus 3, or I could just square the first one. I do minus 2 times the first one times the second one, which would give me 6x. 2 times 3 times x. And then I square the last one, which would give me 9. There's my answer. Let me prove it to you. X squared, negative 3x, which would be negative 6x. And then negative 3 times negative 3 is positive 9. Any questions? Yeah. We have 2x minus 5y squared. So I'm going to take the first thing squared minus 2 times the first thing times the second thing. And then I square the second thing. And that's my answer. 6p minus 1 squared. So I take the first thing squared minus 2 times the first thing times the second thing. And then I do the second thing squared. There's my answer. Alright, this is the answer to a product of a sum and a difference. We've been doing the square of a sum and square of a difference. This is a product of a sum and a difference. So you have a plus b times a minus b. Instead of foiling it and then simplifying, all you have to do is take the first thing squared minus the second thing squared. Alright? So let's do that with 2x squared plus 3 times 2x squared minus 3. Since it's just like a plus b times a minus b, I take the first thing squared minus the second thing squared. There's my answer. Let me prove it. So we take 2x squared times 2x squared. Gives me 4x to the fourth. I take 2x squared times negative 3. I get negative 6x squared. But then I take 3 times 2x squared and I get positive 6x squared, which guess what happens? Cancel each other out. 3 times negative 3 is negative 9. So that's my answer. So I look at this, I see that 3n plus 2 times 3n minus 2 is the product of a sum and a difference. They're the exact same thing. So what I do is I square the first thing, and I subtract the square of the second thing. That's all I do. By the way, this is x, it's supposed to be c. I apologize, I just now realized it. This is the product of a sum and a difference. So I take the first thing squared, and then I subtract the second thing squared. And there's my answer. All right, here's your homework.